is said to be continuous at some point, right?
Yes, sir.
Then
It is breaking at 0.
huh?
Sir, its graph is breaking at 0.
So why it is continuous and why it is not continuous? Then
It should not be continuous.
where?
Sir, graph is breaking at 0.
No. Why it is not continuous or why it is continuous? Is this function continuous or not? At which point it is continuous? At which point this function? See, when I told you the definition of continuity at some point, right? I will check. At some point, continuity you will check. How? It's not it. This way, in sequential way, right? Or this way, epsilon delta way. So, at which point this function is continuous? So, if is
Continuous, sir, for all numbers except 0.
so if is continuous at some C, suppose C belongs to
Real number
real number
except 0.
except 0, right? And if is, so that means if is not continuous
At 0.
at 0. And how you have shown that f is not continuous at 0? How you have shown that this function is not
Sir, because limit is
continuous?
about to infinity.
Yes, so means if you take x tends to 0 plus, then if you take
Limit approaches to plus infinity.
plus infinity, if you take x tends to 0 minus, it will goes minus
Minus.
infinity. So limit does not exist. Limit x tends to 0 plus 0 tends to 0 minus, right? So this function is discontinuous at 0. But the function is continuous at other points. Is not it?
Yes, sir.
So if the function is continuous everywhere in the domain, then we will say that function is continuous on the whole domain. Okay. So similarly, there can be also function which is not continuous anywhere in the domain. Can you give some example? Can you give some example?
GIF.
Huh?
GIF.
Greatest integer function.
No. So is there any function which is not continuous anywhere in the real line?
Anyway, sir, I don't remember,
See,
sir.
earlier we have done it, right? Greatest integer function, right? That it's not continuous at which point? It's not
At
continuous.
Integers.
Huh?
integers.
Yes, only at integer points. Even that integer point is infinite, right? So the function is not continuous at infinite number of points. That is example. But I just want to know whether there is some example. Suppose in the real line, anywhere the function is discontinuous. Can you give some example? And I told you that when you want to show some function is not continuous, right? What you have to do? Best way is to maybe you can use sequential criteria, right? Okay. So suppose this function,
सर वो डिफाइन अपने हिसाब से करें तो हो जाएगा ना जैसे एफ एक्स इज इक्वल टू 1 व्हेन एक्स इज रेशनल ऐसे कुछ टाइप में
x
तो वो अपने
rational,
हिसाब से करें तो और 0 व्हेन
x irrational.
एक्स इज इरेशनल
And then how will show that this function is not continuous at any point c belongs to R. So if is not continuous at any point. How will show this? I will show this.
सर मतलब
So suppose you can take any arbitrary C belongs to R. Then you have to show that this function is not continuous at any arbitrary C, right? And how will show it? I told you in the case of sequence, right? When you want to show that limit does not exist, what you have to do? You have to choose two different sequence, is not it? Such that one should goes to one, another should goes to cat. In this example, you can see what two sequence you have to choose, such that one should goes to one and another should goes to zero. Can you choose it? Can you choose it? Let C belongs to R. Okay. Suppose xn is a sequence. So you have to see, right? This limit extends to C, f of x, whether this holds or not, right? Suppose xn is a sequence, okay, of rational numbers. Okay. Xn is a sequence of rational numbers, okay, such that xn tends to C. Okay. Xn is a sequence of suppose rational number such that xn tends to C. Similarly, you can take yn is a sequence of rational numbers such that irrational numbers. Okay. Yn sequence of irrational number, huh? And converges to C. Okay. Then what will be the f of xn? What will be the f of xn? Where it converts? Where it converts?
zero.
F of xn.
1.
1. And what about f of yn?
0.
Yes. Right. Is it clear? So f of yn converges to 0 and f of xn converges to 1. So f is not continuous at any real number. Is it clear? Let me know if it is not clear. Suppose C belongs to real number, rational number, okay? Suppose C belongs to
Yes,
rational number, okay? Then you know that between so you know density properties, right? Density properties of rational numbers. Density property. What do you mean by density property? That between two any real numbers there exists a rational number. Is not it? Between two any real number there exists a irrational number. Okay. That means if C belongs to U, there should exist a sequence xn, okay, of irrational numbers. So here I have, since I have given notation earlier, so yn of irrational numbers. Since you have to show that this sequence is not continuous, so you can always choose yn of irrational numbers. Yn converges to C. Okay. So this is a sequence of irrational number which converges to 0, like that. So, and you are getting because of the density property. Okay. And since C belongs to Q, so what is your f of C? What is your f of C? in this example?
0.
0. What is f of c belongs to q? When x is rational, this is 1, right? So f of c is 1. But what about f of yn?
0.
0, because yn is a sequence of irrational numbers. And when x is irrational, f of x 0, right? So you can see that f is not continuous at rational points. Similarly, f is not continuous at irrational points. Okay. So when you take some c or d, suppose belongs to irrational number, then what will happen? You will get a sequence of, if suppose d is any irrational number, okay, any irrational number, d is any irrational number, then what will happen? By the density properties, what will happen by the density properties?
There exists a rational number in between two.
Yes, so there exists a rational number, sequence of rational number which converges to rational number which converges to d. Since d is irrational, what is f of d? D is irrational. So what is f of d?
0.
0. If d is irrational,
Rational to 0.
f of d 0. And since Sn is sequence of rational number, what is f of xn?
1.
1, right? So this limit is not same, right? That limit extends to d f of x is not equals to f of d. Okay, so you can prove it in various ways that this function is discontinuous at every point. Is it clear? Let I, that is your closed and bounded interval, okay? Closed and bounded interval, okay? And suppose if I to R is continuous on I, then what will happen? Then if is bounded on I. So if f is a continuous function on a closed and bounded interval, then f is bounded, okay? If a continuous function is defined on a closed and bounded interval, okay, the function should be continuous in a closed and bounded interval. So this I is your closed and bounded, okay? Then what will happen? F is bounded, okay? So this is known as bounded's theorem. So here all these hypotheses are needed, okay, in order to prove this. So can you, if you remove some of the hypotheses, suppose if you remove closeness or boundedness or continuity, then you conclusion may fails, okay, that you may not get boundedness of f, okay. So these all conditions are sufficient, all the conditions. So this is here 1 and 2 condition, and here is 3 condition number 3, that this is continuous on I and this interval should be closed and bounded, okay. These 3 are sufficient conditions, okay, but they are not necessary. Even if suppose this one of condition fails, it may be some continuous function you will get. So let me give you some example, okay. Suppose f of x, okay, for all x in 0 to infinity. Okay. So is this function continuous?
Correct.
So this function is continuous. Is this interval closed? So here f is defined from 0 to infinity to r, like. Okay. Is this interval is closed?
No,
Huh? Is this interval is bounded?
no, sir.
So this is unbounded interval, huh? Is not it? But closed. We have included 0. See, this is unbounded. So hypothesis of this boundedness theorem does not hold. But here you will get that, and this function is bounded. Is this function bounded? Is this function bounded? What do we mean by bounded function? That if suppose I to R is a function, huh? Okay, and if this said to be bounded on I if there exists a constant, okay, if there exists a constant m positive such that mod of fx lesser equals to m for all x belongs to I. Okay, this is a definition of bounded function. Okay, bounded function. What does it say? That if there exists a constant, positive constant, such that mod of fx lesser equals to m for all x in I. For all x in I. So, is this function bounded in this interval? Is this function bounded in this interval? That you should not tell me. Is this function bounded?
Yes,
What
sir.
do you is so? What will be your m? What will be your m? Hmm? What will be your m then? Can you find m such that f of x lesser equals to m for all x in I? Huh? Can you find m? Hmm? You are saying that this bounded. How? What will be your m then?
Sir,
Hmm? Hmm.
unbounded है ये.
Unbounded, right? So, if the hypothesis of the theorem does not hold, then you are getting not the result. You are not getting the
Sir, एक
result,
doubt
right?
है.
Bolo.
Sir, doubt. Sir, if it is the range is minus infinity to 0, would it be bounded?
Which one?
if we assume the range is minus infinity to 0, would it be bounded?
If this is minus infinity to 0, this you are saying?
So would it be bounded? Because
So
there exists m that is bigger than 0.
there exists a m. How? So this is your function, right? This is your
No,
function.
no, sir.
So
Sir, I was a little misjudged.
okay, so do you know what does this mean? Is not it? Okay.
Okay, sir. Thank you, sir.
So if some of the condition violates, then you will not get the conclusion. You may or may not. Okay. But to prove the theorem, you must assume this. If these three condition holds, then the function is bounded. So that means these are sufficient condition. Okay. So what about the closed? This already famous example you have studied. If f of x 1 by x for all x in, this is open, huh? 0, 1. So what will happen? Is this interval bounded? Is this interval bounded? Come on. Is this interval bounded? This is just open 0, closed 1. Is this bounded or not? Huh? Is this interval bounded or not?
So
This is
bounded.
bounded, right? Is this closed?
Bounded.
Okay, this is bounded. Is this closed?
No, sir.
No, because
No, sir.
this 0 is not included, right?
Yes,
So
sir.
not closed.
Not bounded.
So is this function continuous? At this interval, is this function continuous at this interval?
Yes, sir.
Huh?
Yes, sir.
What?
Yes, sir. Continues.
Yes, sir.
Yes,
Continuous. In 0 to 1.
is continuous in open 0, right?
Yes, sir.
So only at 0 is there is difficulty, but we are excluding, right? So this is open 0. So this function is continuous. So in this case, this closeness does not hold. Is this function bounded? Is this function bounded? Huh? Is this function bounded?
Yes, sir.
Okay. So this function is not bounded. So can you give some another example that, so I have given example for this one. One of them is not closed, one of them is not bounded I. Okay. But in both cases, f is quantity. F will be not bounded. Can you give some example? And this will, you can define something using f of x and you can prove it. Can you give? So all these conditions, okay, all the hypotheses are needed. Okay. If you relax some of them, then condition may not hold. Okay. So what will be that example? Suppose g of x is 1 by x when x belongs to 0, 1 and 0 when x equals to not 0, 1. When x equals to 0. Okay. So what is your I now? The function defined g I to r. What is your I now? Right. This is your I now. So is this interval closed and bounded? So 0 is here given separately. Is this function closed and bounded?
Yes, sir. Close and bounded.
Is this function continuous? Is this function continuous on I? Is this function continuous on I? Just now I did it, right? Why it is taking so much time? Is this function continuous on I?
Yes.
Why? Why this function is not continuous on I?
Sir, continuous because it hasn't any unexpected changes in the value.
Is this function is continuous on I?
Sir, discontinuous at 0.
So this function is not continuous on I. Okay, because discontinuous is at the point 0. Already I told you several times. Here also I told where in the Aliyah. See, already I told you in the beginning, and now still then also here also. So, and is this function bounded on I? Is this function bounded on I? Can you get some m such that you can write g of x lesser equals to m for all x in 0, 1? So this g is
Unbounded.
not bounded. So that means whatever you have assumed in this hypothesis, you need that. If you don't assume, then it may not be, you may not get the result. That is f is bounded. But these are all sufficient condition. Okay. These are all sufficient condition. What does that mean? If some condition does not hold, if some of the condition does not hold, still you may get the boundedness of f. Okay. Can you give some example? Suppose f of x, x square, okay, and I is your open 0, closed 1. So is this function closed? This interval?
No,
Is
sir.
it's not closed because 0 is not included. Is this interval
sir.
bounded?
No, sir. Unbounded.
This interval is unbounded. Huh?
Sir, bounded.
So not closed but bounded, right? Is this function continuous on I?
Yes, sir. Continuous.
So this function is continuous. Okay. Is this function bounded on I? Is this function bounded on I? Is this function bounded on I or not?
No, sir.
No. Why? You cannot find a m?
Yes, sir. We did not find the maximum M.
No. Can you find a m such that f of x lesser equals to that m? Can you find a m that m?
No, sir.
No. If you choose m equals to 1, what will happen?
Yes, sir. Yes, sir.
Then why you are saying no? So fx is always this in this interval, whatever fx you will get, and only this is lesser equals to 1, right? So this is bounded. So you can see even the condition does not hold, but still you can get, because these are all sufficient condition. Okay. So you have any doubt or it's clear? So we can choose also other properties, huh? So I'll write some other properties. So suppose f of c, I think I have used this one also in yesterday's class. Let me see somewhere. I have used it or see in neighborhood, huh? So suppose f is a continuous function, okay? Suppose f is continuous at c. If f c is positive, then what will happen? Then, so this is called neighborhood property, okay? Then there exists a neighborhood of c. You can denote like that, delta neighborhood, suppose, huh? Such that what will happen? F of c is positive for all x, you know. Similarly, if f of c is less than 0, then there exists a neighborhood such that this is f of x. F of x such that there exists a neighborhood, okay, f of x less than 0. So what does it tell? If f is continuous at some point, okay, then if c is positive at that point, then there will be a small neighborhood, okay. There also other values nearby that will also positive. Suppose if it is at some point, if for a continuous function only, huh? If at some point it's negative, that means there will be a neighborhood such that for all that point functional value is also negative. Okay. Is it clear? So another property is, suppose if AB2 are closed and bounded, huh? Closed and bounded, continuous. Then what will happen? Then if attains its supremum, and infimum, huh? Okay. Infimum means here bounds only, huh? Infimum, whatever you get, supremum bounds, infimum bound, huh? Suppose f of x equals to x square in some interval, okay? Some interval, suppose -2 to 2. So is this function continuous in this interval?
Yes, sir.
So this is closed and bounded, right? Is
Yes,
this
sir.
function continuous?
Yes, sir. Continue.
Why? Why? I will show that f of x equals to x square continuous. In various ways you can show, right? What are they? What are they? This is a polynomial function, right? Or this is a product of two continuous function x and x. You can say in various ways. So what will be its infimum? And what will be its
0.
0? And what will be its lower bound, upper bound?
4.
4.
4.
So one at 0, you will get lower bound, right? means greatest lower bound. Is not it? At x equals to 0, greatest lower bound attains, right? For f. Similarly, at x equals to 2, f attains supremum. That means the supremum means greatest least upper bound, right? Is it clear, theorem? Is it clear? So there are various properties for continuous function on a closed and bounded interval. Okay, one of the famous property is whatever you have studied till now, that this boundedness and this supremum infimum property. That means maximum minimum values will attain. Supremum when you will attain, that means your maximum, and when infimum will also attain, that is your minimum. Okay. So what do you mean by intermediate value theorem? Huh? So from the name, can you suggest what do you mean by that? So F is A to B to R continuous. Huh? That is the assumption. F should be continuous on a closed and bounded interval. Okay. Then what will happen? If n be any real number between Fa and Fb, then there exists some C, okay, belongs to AB such that f of C should be equals to n. So what does that mean? Suppose here is your some continuous function, okay, some continuous function, okay, like that. So suppose here is your f of A, this value is f of A, okay, and here suppose this value is your f of B, and suppose n is some numbers between Fa and Fb, then what will happen? There should be some value here C such that f of C will be n. This is only for continuous function in a closed and bounded interval. Okay. That means what will happen? So if f is continuous, okay, and I subset of AB is an interval, then Fi is also an interval. That means, between Fa and Fb, you will get all the points, some values of them. Can you give some example? Can you give some example? So here similarly, that this condition is sufficient, that if f is continuous on a closed and bounded interval, okay, that means if it does not hold continuity or something, some of the properties, then still you may get. And also like if this condition violates some of them, then you may not get also. Okay. Is it clear? Is it clear? So this is the famous property, okay? So suppose when you want to find some root of the, and suppose it's like graph is a suppose, so this is your f of a and this is your f of b, okay? So if f is continuous in closed interval ab and if f less than 0, then what will happen? Then there exists c, okay, in this such that f of c would be equals to 0. That means this c is a root of f, okay? C is a root of f. These are all application of this. Is it clear? And
Yes,
this
sir.
is very useful. This is very useful. Okay? This is very useful. Till now, you have any question? Suppose if a to b to a to b continuous on AB. So you have to prove that there exists C belongs to B. So this is also sometimes called Bolzano's theorem, Bolzano. Okay, Bolzano property. So can you prove this? Can you prove this? What do you have to prove? That you have to prove this, right? There is C such that I'll prove it. I will prove it. You have to use this one. I'll prove it. What you have to consider? What you have to consider? So here you are assuming, suppose f of a equals to a. Then already proof is done, equals to b. Okay. Then how will show? Then how will show it? Then how will show it? That for this, suppose f of a, that means f of a always belongs to a to b, right? F of a not equals to, that means f of a should be greater than a, is not it? And here f of b, b is also belongs to f of a b. And since f of b not equals to, that means f of b should be less than b. Is not it? Now suppose you choose some function phi x equals to f of x minus x. What is phi of a? What is phi of a? What is phi of a?
A minus A.
And what will be that? What will be that? See,
Greater than zero.
huh?
Greater than zero. Greater than zero.
Greater than 0, right? What about phi of b?
Plus B minus B.
And that is?
Less than zero.
Then what is your conclusion? See, the f is already continuous, right? So this phi x is already continuous in closed interval AB. Okay. So what will be your conclusion now? What will be your conclusion now? What will be your conclusion now? If some function is continuous in closed interval AB, and if f of a, f of b less than 0, then there exists c such that f of c is 0, right? So what you should write now? That there exists some c belongs to, there exists some c belongs to AB, because already you have
AB.
seen. What will happen then?
FC equal to zero.
Uh,
FC equal to zero.
f equals to 0. Is this your conclusion? Check again. If some function is continuous and f of b less than 0, then there is c such that f of c 0. So what will be conclusion here? What is your conclusion here? Phi of c equals to 0. Is not it? Phi a, phi b less than 0, right? Is it clear? And phi of c 0 implies f of c equals to c. Okay? Is it clear or not?
Sir.
Is it clear or not?
Yes, sir.
Okay. Any other question? Suppose f of x equals to x minus cos x. Okay. Suppose we have to find that whether in 0 pi by 2, whether it has a zeros or not. How will find it? This is the function. Okay. This is the interval. You have to find that in this interval, this has a root. How will find it? You don't have to find, just you have to show that it has a root. How will do it? How will do it? What you have to do? First, you have to check whether f is
Continuous or not.
in this closed and bounded interval. Then what you have to check? Whether f of, what you have to check? Whether, what you have to check? Whether f of 0, f of pi by 2 should be less than
Less than zero.
0. That means this should be of, this should be of opposite sign. Is not it?
Yes, sir.
So what will be your f of 0?
Minus one.
f of 0 is -1. That is strictly less than 0. What about f of pi by 2?
Pi by 2.
Huh? Pi by 2, right?
Pi by 2.
And that is positive. So, what is your conclusion now? Using intermediate value property, you can say that there exists some C
C. Where
belongs
f
to
is equal,
such
where
that
f is equal to 0.
f of c equals to 0. That means this has a root, right? This function has a root in this interval. Is it okay? Okay, so we'll continue here, huh? It's almost finished. Continuity. If you have any difficulty till continuity, you can ask Monday, huh? On Monday. Okay.